Thank you everyone for joining. I'll go ahead and do our brief introduction while the last couple of people log in here. To introduce myself, my name is Teresa Worth. I'm the program manager of the MECI Alliance at MIT's Department of Mechanical Engineering. I'd like to thank you all for joining us for this week's MECI Alliance seminar. Our speaker this week is Mitch Kelly. Mitch graduated from MIT with a bachelor's degree in mechanical engineering in 2011. He started his engineering career making direct applications of the 2006 and 2009 course material as a thermal fluidics product development engineer. While completing a part-time online master's degree in mechanical engineering at Georgia Tech and developing novel CAD/CAM systems, he realized how fun and useful software engineering methods could be. He now works as a software engineer at Facebook Reality Labs, advancing the frontier of augmented and virtual reality technology. And he's looking forward to a future of ubiquitous, world-aligned engineering, design, and collaboration tools and resource lifestyle optimized manufacturing systems. Today, Mitch is going to share about his MECI Charmed Reality, sharing metaphors and insights between mechanical and software engineering. With that, I would like to thank you again, Mitch, for joining. I'm going to stop sharing so you can put up your slides and get us started. Thank you.
Thank you for the introduction, Teresa. It's a pleasure to be here and speak with you about my experience. Let me just share my screen. Okay. Yeah, I was speaking with Professor Wang a few months ago, and we got to talking about career stuff, and I shared that I had switched into software, and she invited me to speak today, and it's really a privilege to be able to do so. I've been very impressed with this series, and I'm humbled to be participating. I titled the theme of this talk MECI Charmed Reality, with inspiration from the Third Eye Blind song, Semi-Charmed Life, with the refrain, I need something else to get me through this semi-charmed kind of life. And it's really an elated song about somebody who's very happy, but finding some other ways to maybe enhance that life. And I hope that in this talk, I can share some insights that I've had doing software and mechanical engineering, really enjoying mechanical engineering, and then finding ways to make it better through some software tools and skills. So my goal with this talk is to encourage you to learn to take advantage of software engineering tools and skills for greater fun, expression, and capabilities. I started my career entirely in mechanical engineering and am now working entirely in software engineering. There's a lot of exciting work that occurs at the intersection of software and mechanical engineering, and I would like to encourage you to embrace that space and create great things in our digitized world. A quick note on the format of the presentation, please feel free to listen to the audio only. My slides are kind of boring, not worth looking into unless you want to check a reference that I mentioned. I've listed some links and keywords. I'll just quickly click through those so you have a visual on them, reference, and to give an overview of what I'll cover. A career overview, some internship thoughts and experiences, my undergrad perspective, graduate school, working as a mechanical engineer, working as a software engineer, and some really great tools that you have access to in software, Linux and command lines, text editors, version control systems, structured data, and query languages, different analysis techniques and debugging tools, some hobbies, and recommended programming languages, more thoughts on programming languages, and some learning materials, podcasts, and potential project milestones if you're interested in stepping deeper into software. So to give a quick overview of my career, I grew up in Attleboro, Mass. I've lived in New England most of my life. I graduated from MIT with a bachelor's degree, as Teresa explained, in 2011. I did some internships, including one with Misty Germany in Munich. After I graduated, I worked for 5 years as a mechanical engineer while pursuing an online master's degree in Georgia Tech. I got involved with CAD and really enjoyed the software development process and decided to try to increase my skills there. I felt like it was increasing my capabilities as a mechanical engineer, but I thought there might be some knowledge gaps. So I really focused on those and ultimately transitioned into software 5 years ago. Now I work at Facebook Reality Labs, and it's been really fun. I've been excited about AR VR for a long time. I'm not talking about my current work today, but I'd love to answer any questions you have about the experience of switching careers or learning to program. So I gained a lot of perspective on engineering through my internships. I've always had part-time jobs through middle and high school. I enjoyed having a paper route, working as a caterer, but I was really excited to get my first engineering internship at Barry Industries the summer before freshman year. At Barry Industries, I had the opportunity to work out in a lot of the manufacturing process steps in a precision electronics component factory. It was really an amazing overview of modern manufacturing processes and the practical details of making something. Kind of like the show How It's Made. I really love that show. I felt like I was in one of those factories right in high school. I got to use SolidWorks for the first time in Barry Industries, and it felt like computers were living up to their promise. At the same time, I couldn't help feeling constrained by the design choices of the program, but you have to work, you have to take what you can get when you cannot write your own software. Then as a freshman into sophomore summer, I worked at the Media Lab. That was really fun. I saw a lot of cool creative applications in software and hardware. At the time, I was a big fan of Guitar Hero and fascinated by how quickly you could become skilled at playing the virtual guitar, but at the same time, not play a real guitar. And I thought there might be some way that a better product could fix that. And it happened that Craig Lewiston was working on that exact idea in the Opera of the Future group. And I got to collaborate with him on making a piano that would teach you how to play by actuating your fingers and giving you muscle memory. Sophomore year, I took a thermal fluids engineering class and really loved the complex system interactions. So that summer I worked for Professor Wang and Arthur Correa to make a highly efficient heat sink for the Doppler challenge. The project involved characterizing the flow properties of sintered heat pipes, and that meant measuring the pressure drop at different flow rates. So I took the opportunity to write a slope detection program to extract and visually confirm the key steady state data points. And it was the first time software resulted in a significant productivity gain, and it got me hooked. Junior year onwards, I continued doing more with MATLAB for lab reports and little projects. I was pretty competent when I started an internship in Munich with Deutsche Bahn and was responsible for creating analysis tools for trackside aerodynamic measurement campaigns. Reading and writing Scilab code with French documentation and German comments was a fun challenge. Not the most efficient way to learn, but a confidence booster by the end. And I have a few thoughts on internships. Definitely do them and focus on maximizing your learning. There are a lot of interesting fields, and an internship is probably the best way to explore a new area. Funny story, I had a negative experience in the internship search process where I sort of said that I would like to work for this ocean research company if I could go out on the boat. And the hiring manager interpreted that negatively and suggested that I should be a lifeguard instead. It was embarrassing, but maybe it would have been better for me to have been a lifeguard anyway, who knows. I think your internship choices do matter, and while it's a good opportunity to explore new areas, you should think about whether you'd like to work in that company or field in the long term. In undergrad, I really enjoyed my coursework and experience. A few things that really stood out are my time at the Media Lab, the toy product design, thermal fluids, manufacturing, and product design courses. A few things that I wish I had done differently in hindsight. I would have loved to have taken the class How to Make Almost Anything through the Media Lab. I only learned about it after graduation, but have found the course materials really helpful and interesting, and there are a lot of cool student projects that come out of the class. I also wish I had done my humanities concentration in science, technology, and society or music. I did econ because it seemed practical, but I did not enjoy it, and I believe an area that I was more excited about would have been better. I regret missing out on some robotics opportunities. In 2007, I opted to join friends in the SAE variant, which was cool, but I think I would have gotten more from the robotics course. I recommend participating in MATLAB or BattleCode during IAP if you have the chance. Generally, I could have leveraged software more effectively to manage coursework and tasks, and if only to better use the Athena Linux cluster more effectively. And then for graduate school, when I interned in Germany, I got the impression that a graduate degree was necessary in order to work on interesting projects. And since then, I've learned that it might be more true in Germany than America. I'm not sure, but it was a motivating factor for me. I did not know exactly what I wanted to specialize in, and that was a big disadvantage. I think you should be very excited about your specialty before beginning grad school. My coursework and experience was oriented towards thermal fluids, but I wasn't necessarily ready to commit to a specialization. Ultimately, Georgia Tech's part-time online master's program was perfect for me at the time. It allowed me to have a full-time job, but also work towards a degree on a timeline that would allow me to customize my education as I got a better sense of what I wanted. At the same time, online education was not as ubiquitous as it has become this year. I reassured myself that it was okay because Arnold Schwarzenegger earned his acting degree in the mail-in video program while lifting weights, and it worked out for him. The point in my master's program where I got really excited was when I took a CAD systems course and pursued the independent project to develop a customizable CAD system inspired by some of the software development tools I'd come to love. This project pushed me to learn more about software development and ultimately gave me confidence to pursue a full-time role in software. I had a great advisor, Professor Rosen, who pushed me to think in a scientific way. I got a conference paper and talk accepted under his guidance and met him for the first time in person at the ASME IDETC Computers and Information Engineering Conference. And to finish my last two course requirements, I used my electives to take a reinforcement learning course out of the computer science department. And that has been my only formal CS education. And by the way, I recommend the Georgia Tech Online Masters in Computer Science. It's well organized, flexible, and affordable. A funny experience, while taking an engineering design class, Professor Schaefer challenged us to envision and design for the world of 2020. I was only planning for the Internet of Things and 3D printing. He also suggested that the world did not need another coffee maker. And meanwhile, I was developing a new coffee maker for a client in my full-time job. And one final thought on grad school. Go to grad school if it suits your goals, not because someone else said it might be a good idea. And as far as working as a mechanical engineer goes, I won't go into too much detail. I think information management is key. Sometimes I felt disorganized relative to the machinists, and it might be worth comparing your file system organization to a well-maintained machine room. Working as a software engineer, I've really enjoyed it. It's not too different from working as a mechanical engineer. One of my past directors encouraged the software engineers to think like scientists. It's a funny thing to say, but it can be easy to get distracted by process and overlook better approaches to problems. Two main things that stand out in software are fast build times with instant feedback and the fact that the design, the code, is essentially the product. You don't need to pass the work over to another department for fabrication, and you don't need to wait a long time to know if your design will work. And I think rapid manufacturing can help here. Another thing that's nice is, like a machinist who makes fixtures to help with fabrication, software engineers often make their own tools to help create software. In fact, it's common to refer to helper functions in validation tests as fixtures. And then a few reflections. As a mechanical engineer, I got a lot of satisfaction from showing people things I made. I also drew a lot of inspiration from interacting with the physical artifacts. In software, things are obviously a lot less tangible. You spend so much time working at a computer, it's worth optimizing the experience, but to what extent? There's a temptation to make hotkeys and helper programs for all activities, but you only remember and reuse certain workflows. So there's this tension between workflow optimization and dependency minimization. It's sometimes referred to as bike shedding because it's not worth building a shed for bike. Another little peeve is when people call computers machines, but I find myself doing that now too. Now to get into some like the real meat, some tools that I'd like to encourage you to explore if you're not already using them. Linux and the command line tools available to you. When I was at MIT, I was not comfortable using Linux or command line tools. I think it was a huge loss. If you want to learn something that adds immediate value to your non-trivial computer activities, I recommend getting comfortable with the Linux-style command line tools. Command line tools can be thought of as a magic wand. If you know the right words, you can do things that your old self would think are magic. There are a few simple commands that can do everything you do with graphical file browsers. Linux allows you to pass the output of one command to the input of another with the pipe operator. And here's a simple example that finds all your to-do statements and writes them to a file, records your daily task count. And this can be run on a daily basis with the cron tool. It's a simple example, but shows how you can save a lot of tedious clicking with a simple program. And yes, by the way, if you put this command in a file and mark it as executable, you could consider this a program. At MIT, Linux is available in the Athena cluster. Chances are you have access to it on your computer as well. Macs can run these commands by default. Windows can run Linux commands if you enable the Windows subsystem for Linux or install MinGW. The command line experience is especially convenient when connecting to a remote server. While it would be possible to stream graphical environment to your local computer, you can't beat the low resource, low latency command line interface when working over a network. It's worth noting that most of the cloud computing providers like AWS, Microsoft Azure, or Google Cloud Platform offer basic free Linux servers as a means to introduce you to the platform. It's a good way to get started without having to install anything because you can use the command line through the browser. And you might think that typing in a terminal is tedious and annoying. It can be, but in practice rarely is when you take advantage of all the capabilities. There are a lot of tools that make this a highly productive environment. To name a few, SSH allows you to connect to a remote server. Tmux lets you run multiple command lines within a single remote connection. And command line environments like Bash will often include hotkeys such as the readline library that let you navigate along the command line efficiently. For example, if you press Control R, you can search through your recent command history, so you don't need to type a full verbose command more than once. Text editors are a really nice feature of the software engineering toolkit, something of a contentious topic, but because everybody has their preference. But typing really is not as tedious as you might think with text completion, intuitive hotkeys, navigation, extensibility, and auto formatting and automatic checkers. There are a lot to choose from. Vim and Emacs are sort of editors, but also interaction paradigms, and they have been ported over to many other environments. VS Code is probably the most popular one right now. I recommend it if you are not using any of these. It's a good way to get started and gets you access to a lot of nice convenience features that can really expedite your process and keep you engaged with the work. Programmable keyboards are helpful too, but only to an extent. And version control really is a special thing. I think it's been ported over to a lot of other computing environments, but really a standout tool in software engineering. You never lose that old version of your file. And the process of storing your data in a version control system comes with inherent documentation in the form of comments when you write a change, or the ability to compare different versions of a file. It's especially useful. You can also collaborate with many people in this paradigm, avoid overwriting or coordinate through peer reviews. It's also just easy to back up to a lot of locations. And some of the popular tools are Git, probably the most popular, Mercurial, Perforce, and SVN. Then another sort of gem of computer science is data structures and ways of thinking about data. It really shouldn't be siloed. In course 6, I think everybody would benefit from understanding how to model data in sort of the object-oriented programming paradigm. And if you're not familiar with this, I think it's worth learning Java or C++ for that sole purpose. We use Excel a lot by default because it's available on most computers and most environments. It's really popular in companies, but you can only store so much in a table format, or a single table format, I should say. And if you're not familiar with JSON or YAML, I encourage you to take a look. It's a really convenient way of, it's a language agnostic way of describing data. Here's a trivial example describing maybe myself, where you can nest data in different association formats with here a map or an array at various steps. You can specify a schema to enforce data constraints. And I'd be remiss not to mention SQL, which is a structured query language. And that is a means of interacting with relational databases. Without going too much into it, it's a way of modeling and efficiently accessing, storing, querying data. It's used in basically every application that you interact with. And here's a simple query, how you can read data from a database. It's very expressive. Key database programs in relational databases are MySQL and SQLite. MySQL's powering a lot of the websites that you visit, and SQLite is running on the client side, usually in your phone or browser. And these are open source projects, which is another nice facet of the software world. You can make something and share it very easily. And I just love this phrase from the SQLite website on the About section. I'll jump ahead because we're short on time. And another mental framework in software engineering is complexity analysis, and then also the process of debugging. I think of these as maybe the design phase when you're trying to coordinate with your team what to make, how to make it, anticipate how it will perform. You speak in terms of this big O notation. So application to manufacturing. And I think this is a valuable concept for manufactured systems, is thinking about how your strategy might influence overall time to produce a product. A trivial example, if you're labeling boxes that are in trucks, the time complexity to apply a unique label might be on the order of the number of boxes times the number of trucks. And the space complexity here might be just on the order of 1, because you just need to store the integer, how many labels have I already labeled, and increment that integer as you go through. This is like very familiar concept in software, but I feel like it's underutilized in other engineering domains. I found it helpful as a mechanical engineer when working on a motion mechanism for a 3D printer to think about this, and I realized that we could remove some costs from the system by taking out the active z-axis and just using the motion of the XY axes outside of the print domain to index the z-axis up and down. And this ultimately resulted in a patent. And was something that was directly inspired by some of my software activities. Just thinking about how we could eliminate the cost, leverage the necessary complexity, cut out the unnecessary complexity. And then when you actually make something, you need to fix it. We have the process that I'm very familiar with of attaching thermocouples. And I think the analog to that in software is adding log statements throughout your code. It's pretty quick and pretty similar to finding hotspots. Thermal imaging is another way to get sort of a bulk perspective on a physical object. And we have a tool for getting stack traces that will tell you the time to execute every incremental function in a function call. And those can be visualized in a flame graph, which is surprisingly similar, in concept and visualization. And then there's a concept of stop the line introduced by Toyota when they were revamping and ultimately improving their manufacturing process. This pioneered the Scrum and Agile methods that are popular in software development. So if something's going wrong on your factory line, operators have the opportunity to hit a button and shut down the line, stop everything. That's oddly similar in my mind to a debugger and breakpoints. Just useful tools when you're developing software. A few thoughts on some hobbies. I think what you do in your free time matters. It contributes to your well-being and career opportunities. If you have more time than you think, if you be honest with yourself. I have a personal tendency to prefer hobbies that increase my capabilities. I sort of played piano in elementary school and clarinet in middle school, but never really got comfortable with music. I regretted that for a while, and I thought I wasn't a musician, so I couldn't be a musician. And that didn't make sense, I know, but I think a lot of people tell themselves that about a lot of things. For a long time, I didn't think I could be a computer programmer because I wasn't good at programming. Anyway, I learned how to play guitar and violin a few years back, and it's been a great source of joy. I really like making things at various times. That's been small 3D printed or electronics projects. For a while, I was excited about computer-powered art projects. I like running because I can listen to podcasts and audiobooks while I do it. I think more clearly when I'm exercising regularly. And I was training for a marathon when I was preparing to switch into software, literally. And I listened to the entire Programming Throwdown podcast along the way. And it was super helpful. An idea that struck with me from 200B is that toys are tools for learning. And if you're thinking of switching careers, you need to stay motivated. So aligning your free time activities with your goals will help. Recommended programming languages. I think it's really not about the language itself. It's about what your peers are using, what your friends can support you in, and what was used for the open source project that you might want to work on. That's how I have thought about it. But I also have some perspectives on the languages that I have more experience with. MATLAB and Scilab are more familiar to engineers, good starting points. Python is very popular. I like it for short scripts or plotting data. JavaScript and TypeScript are ubiquitous and I think worth using, if only to get access to the React.js and Three.js libraries. There's a really big community in JavaScript. Golang is fast, clean, compact. There's good community. C++ is my personal favorite, and it seems to be the de facto standard when people talk about algorithms or capabilities of computers. A lot of details can be extracted in higher level programming languages, but they are all relevant in C++. So lots to learn, but very expressive. Java is a nice language, popular for large projects. And processing and Arduino are dialects of Java and C++ or C, but really well oriented to get into programming, and lots of good examples, motivating examples. As far as other learning resources, Stack Overflow is probably the top result whenever you accurately phrase your question about how to do something with a computer. So check that out if you don't know about it. And GitHub has lots of code samples to show you how to do something if you're interested in new concepts. CPP reference is a C++ specific resource, but it's very well organized and can often give you good context. I think Paul Graham's thoughts on software are helpful and motivating. And the book Cracking the Coding Interview is well organized with a high-level overview of concepts that you can use as a jumping off point to fill in any gaps in your knowledge. And there are lots and lots of blogs and good online learning resources. So I just recommend finding some that work for you. I really liked creative coding when I was learning how to program. And so I gravitated towards those resources. One challenge when learning to program is finding a resource that's both approachable and engaging with a non-trivial scope. And I felt like the processing language and community was really well scoped for getting into and then succeeding in software. So I recommend that. Podcasts, when I commute, run, or do chores, I listen to a lot of podcasts and audiobooks. Programmer Throwdown I mentioned, that was my favorite for a long time. It's sort of like hanging out at the water cooler at a software company. They talk about interesting tech content, but also contextual information that helps it sink in. And CPP Cast is really interesting and good on heavy technical content. It's a good way to get a glimpse of the frontier of practical software engineering through the lens of how the C++ community is evolving the language. And just for fun, I really like Myths and Legends, The Portal, The Breakfast Club, and Dave Ramsey has been a useful and fun financial podcast, great for practical guidance on getting out of debt and saving for retirement. But as far as stepping into software development, if you're not already doing it, or if you're somewhat comfortable, here's potentially an outline of how you might think about leveling up. Hello world is always the default, but yeah, maybe write to file, read to file. Some other milestones, working with databases, web page, and yeah, sort of as you go. I've gotten a lot of satisfaction from working with software, and I think it will help you in really any endeavor that you're pursuing. So many things are getting APIs now. It's worth having some familiarity with the technology. So yeah, that's my perspective, and I'm happy to answer any questions. If there's anything that you'd like to know about learning software or switching careers.
Great, thank you so much, Mitch. So thank you, Arun, for finding the Q&A. For the other attendees as well, you can either raise your hand or type your question into the Q&A. I'll go ahead and get started with Arun's question. For building portfolio projects, are Internet of Things projects considered relevant in the software domain?
Yeah, I think totally. It's hard to draw a crisp boundary around what's relevant in software. IoT is more relevant in certain companies, as you expect. But if it's something that you're excited about, it's definitely a good way to increase your software skills, your portfolio. Yeah, companies are looking for people that are excited by what they're doing and can, and a lot of times I think that's necessary to develop the real skills that you need, because sometimes it's a grind when the compiler is giving you errors, and you have to be able to get over that. And I think doing something that you love, if that's IoT, is a good way to do that.
Yeah, definitely. Um, Yeah, and I really appreciated the way that you structured your talk today. There's so much here I think students can really go back to. And I'm really hearing how this learning more software development skills can be a really good general tool set. And I think with everything that is happening right now, so many teams are multidisciplinary. I'm imagining even just having a general understanding of some of these concepts would help in collaborating with software engineers in the workplace. So this is really helpful. Janice has a question. She says, you said you took very few actual computer science courses. So did you teach yourself all these languages and skills, or was there some other ways that you learned these skills?
Yeah, it's a good question. Yeah, I only took one class in grad school, at which point I was already working at a software company. We did have a class on MATLAB. Well, maybe I guess a lab component of a class that involved using MATLAB. And that was helpful as a kick into action. So if taking a class will kick you into action, I think you should go for it. But yeah, I really leveraged online resources, friends. When I was making this transition, I was living with some friends from college, two of whom had done course 6, and they were very helpful for all my questions. So that's why I suggest you should learn a language that your friends are using, or people in your community, so that you can discuss it with them. There are, I mean, you can answer any question online, but a lot of times it's more efficient to talk to somebody that you trust.
Yeah, that makes sense. And sometimes I find one might not necessarily know the right question to get a really broad answer to. So that's a really good point. I had a question as you were talking to. I'm wondering if being on a software development team as a mechanical engineer, if there are ever instances where your mechanical engineering perspective really brought like a new idea or a new way of thinking to that team that was maybe unexpected for you or for your team. Yeah.
Yeah, I think so.
I'm putting you on the spot to think of an example.
Well,
General themes. Are there anything in general where you see that maybe people who have a traditional background in computer science have a different way of thinking?
yeah, it'll definitely. The example that I like to use is comparing CAD systems to the output, the error output of like a crashing program or debugger. CAD system, you can really zoom in, look at, investigate the 3D model. And with a program, sometimes it's opaque if you haven't set it up correctly, or if it's not something that you've worked with before. There is not as much instant knowledge transfer as you would get in like the visualized environment of a CAD system. So at actually my last company, we were developing distributed systems, and one of our products, an open source product, was this debugger for distributed systems. And it had this cool property where you could jump from the execution of one isolated binary program over to another one, and your debuggers would be synchronized, and they'd follow the code path. And it in the domain, it was a radical idea, but sort of as a mechanical engineer, I expected that kind of observability. But yeah, software engineers are really fighting for the phrase observability and traceability in distributed systems, especially where it's hard to identify where a problem is coming from. So I think the sort of intuitive, visual, and physical nature of mechanical engineering is an advantage, if only for like setting your expectations.
Yeah.
And that also motivated me to pursue course 2 anyway, because I felt like, well, at MIT we have these amazing labs, and I could use a computer anywhere. So I'd like to be in the lab. And it was more intuitive also. to be honest, I didn't really think of myself as a computer person in high school. And yeah, I think leveraging what makes sense to you makes sense to me.
Yeah, that makes a lot of sense. I'm a very visual person too. So when I think about code, I'm just like, but I don't understand. So yeah, it makes a lot of sense. So that's as well as I can explain my thought as with a non-technical background. Bob Green has more of a comment, but I'll turn it into a question for you. And I will say it's the last question. So Bob says he's a longtime developer, and he found that practicing reading other people's code was really helpful, and that over time you end up reading much more code than you write. And that it also takes time, and that he also suggested take time to teach yourself to learn the fundamentals of things like compilers, computer art, operation systems, and networking. So I guess as a final question for you, have you found that to be the case as well? Do you find yourself reading a lot of code? Are there places that you suggest for finding these resources, sort of thing?
Oh yeah,
and
definitely.
I'll pull up my closing slides while you answer.
Yeah, that's a good point. In a software company, one of your core responsibilities is ensuring that good code makes it to production, and there's a lot of peer review, reading a lot of other people's code, or if you're trying to integrate with another library that will involve some code investigation, and getting comfortable with that is really valuable and important. You can find lots of code examples of mixed quality online, but
yeah, I would imagine.
yeah, GitHub has just an incredible wealth of open source code that you can browse through. And yeah, I think it helps, like Bob said, pushing yourself out of your comfort zone into various domains. I think that's really important. If there's something you don't understand, or if there's a library that you're leaning very heavily on, it's helpful to try to think about how that library was implemented, and if possible, go down and read through it and try to understand it yourself, and then you can integrate those lessons into your own products.
Yeah, great. Thank you so much. And thank you again for being here. This is really informative. I don't often ask this, but if you don't mind sharing your slides, I feel like you have so many resources that you linked. I'd love to forward that on to our students. I'm sure anybody could sit and spend some time with that and really find some interesting avenues of learning. So thank you again. To our attendees, thank you for joining. I'd just like to highlight our next week's seminar. Next week, we'll be hearing from Carlos Portela, who is actually a new faculty member in mechanical engineering. He'll be sharing with us about his work on developing avenues towards 3D architect materials beyond the laboratory. So please do join us next week at the same time. And thank you again, Mitch, and for everyone for joining.
Thank you, Teresa.
Enjoy the rest of your day. Thanks. I'm gonna find my end button. Bye.